हेलो बोलो।
हेलो हेलो।
नहीं आ रहा, अब आ रहा। बोलो।
हेलो।
वो शेयरिंग की है।
Was I audible?
अरे और निश्चित श्रीवास्तव क्या किया? अगर कुछ नहीं कर रहा तो तुम मेरा साथ काम कर लो फिर।
फ्राइडे को सर मिलने को बोला है।
बदमाश कहेगा। हमारा पास बहुत काम है।
काम उनको बोले थे
1 plus 2 plus 3 plus 29
What are you doing, Akhya?
Oh, I was just calculating something.
Oh, is it so?
Yes, isn't this what we are here for? Mathematics is a methodical application of matter. It is so said because the subject makes a man the subject makes a man methodical or systematic. Mathematics makes our life orderly and prevents chaos.
Certain qualities that are nurtured by mathematics are power of reasoning, creativity, abstract or spatial thinking, critical thinking, problem solving ability, and even communication skills.
Mathematics is the cradle of all creations, without which the world cannot move an inch. Be it a cook or a farmer, a carpenter or a mechanic, a shopkeeper or a doctor, an engineer or a scientist, a musician or a magician, everyone needs mathematics in their day to day life.
When this is a necessity, then why shall we not make it a learning activity for every learner?
Yes, this is what we are here for. Today, I, Akhya Budhwar,
And I, Khushi Jain,
greet you all to the welcome ceremony of Mathematica 2020 organized by Allen House Public School, Khalasi Lines, Kanpur.
we welcome respected Purnima Das,
Honorable judges Dr. V.K. Mishra, Ms. Aparna Mukherjee, and esteemed guests of the day Dr. Arvind Kumar Singh and Professor Lakshmidhar Behera.
let us now join our hands to seek blessings from the God Almighty.
I now take this opportunity to introduce and greet the participating schools. We begin with DPS Delhi Public School, Indiranagar. Dr. Soni Lal Patel Secondary School, Delhi Public School, Kalyanpur. Allen House Public School, Jhansi. Allen House Public School, Vasundhara. Asian International School, Howrah. Allen House Public School, Ruma. Rapid Global School, Biduna. St. Joseph Senior Secondary School, Jajmau. Mariambo Senior Secondary School, Shastri-Nagar. Delhi Public School, Gomti-Nagar. Army Public School, Camp. Dr. Viren Charu Public School, Kalyanpur. Delhi Public Kanchipuram. Allen House Public School, Khalasiline. City Montessori School, Rajendra Nagar. City Montessori School, Indiranagar. Artis Education Center, Shyamnagar. Ambika Prasad Memorial School, Shitlaganj. Allen House Public School, Vrindavan Yojana. Delhi Public School, Elgico. Pandit Deen Dayal Upadhyay Sanatan Dharm Vidyalaya, Nawabganj. I now request Vice Principal Ma'am to welcome the guests of the day.
Well, good morning, everyone. Actually, I find the warmth missing this morning only because of the network issues. I will take this opportunity. Dr. Arvind Kumar Singh, Associate Professor, Department of Mathematics, Institute of Science, Banaras Hindu University, Varanasi. Dr. Saab did his MSc from Lucknow University and PhD as well. He was 2000, he was JRF and then got fellowship in NBHM in 2004. Joined postdoctoral fellow in IIT Kharagpur and joined as an assistant professor in 2007 in Banaras Hindu University. A very warm welcome, Dr. Saab. I'm sure that your presence here will make all the difference that it should to subject like maths. Our second guest is none other than Professor Lakshmidhar Behra, Senior Professor from Electrical Department, IIT Kanpur. And he finds to talk about his success in a very different term. I'm sure he also must be having a long list of achievements where his subjects are concerned. But he wished to be introduced as somebody who has initiated ISKCON Temple in Kanpur. He is also the director of ISKCON Gurukul Vrindavan, director of Bhagavad Gita Pathshala, Learn Gita Live. Gita, millions of people over the world are associated with this initiative and learn Bhagavad Gita. What a beautiful introduction, Dr. Professor, sir, because I'm sure you must be having many more in your kitty. But how we choose to be introduced and showcase ourselves to the world is actually what I think we really are. On the same lines, I'm sure our judges would be here. Would like to welcome Mr. V.K. Mishra, Principal, DPS Bareilly. He is one of our judges, principal since last 10 years and teaching experience of 21, illustrious career, I can say. He is MSc Maths with professional training as well. He is a British Council School Ambassador for North India, certificates in leading culturally diverse team from Deakin University, Australia, certificate in managing mental health for Coventry University, UK, certificate in embracing digital technology and business management from King's College, London, certificate in neuro leadership from Central Queensland University, Australia, certificate in guidance and counseling from IGNOU, India, city coordinator of CBSE since last 7 years. He's been a subject expert of maths as a PGT, I'm sure, associated with Generation Global, a Tony Blair Foundation, UK, member of organizing committee of Inspire Science Camp, a project of Department of Science and Technology, Government of India, received Atal Shiksha Ratan Samman. We welcome you, sir. We also have Mrs. Arpana Mukherjee. Ma'am, you are welcome. You're a maths coordinator, having around 15 years of teaching experience through various activities. Have been a great strength behind numerous webinars being conducted pan-India of mathematics. We welcome you all to this beautiful event. Would remain my personal favorite because I never liked maths. So to see people, working towards it and creating interest, so I can not very proudly say I have been one of the victim of subject called maths. And it is beautiful that under our leadership, we are propagating maths. So we have not been vindictive people. I will give that credit to ourselves also. Thank you so much and welcome all, and let us continue.
Thank you, ma'am. To reach new heights, conquer new summits, we have torchbearers amongst us. We will now invite Sir Arvind Kumar Singh to enlighten us with his realms of knowledge.
So thanks to introduce me. I think I am audible to everyone. Is it audible? Hello?
Yes,
Hello.
sir.
Okay, thank you. So good morning to all of you. Respected principal, first of all, I would like to be thankful for the coordinator who invited me on this occasion. And I am also grateful at this occasion for the principal of the Allen House Public School. The other, I also welcome Professor Dr. Lakshmidhar Behra, IIT Kanpur, and the judges, Dr. V.K. Misra and CBSE, who was also the CBSE coordinator, and Mrs. Arpana Mukherjee. Dear students, and students of other schools who are participating in this occasion. So first of all, you can, as principal, your principal told us that she never liked mathematics. So this is very unfortunate because mathematics can never be seen like this. And as being mathematician, it is very depressing for me. But no way. First of all, I would like to quote some famous quotes. According to C.F. Gass, who is the mathematician and physicist, mathematics is the queen of science, right? And you never deny it, right? I think you all know very well Swami Vivekanand. According to Swami Vivekanand, you know how many sciences had their origin in India. Mathematics began there, right? You are even today counting 1, 2, 3, etc. to 0 after Sanskrit figures, and you will know, you all know that algebra also originated in India. So this is according to Swami Vivekanand, right? So with this famous words, the importance of mathematics has never been greater than now, because mathematical skills are concerned for whole array of analytical, technological, scientific, and economic applications, right? So I am confident that this platform will be beneficial to all young students. And You know, mathematics is often a dreaded subject for the learners, as your principal told. But this fear of mathematics makes it difficult to make mathematics enjoyable, right? So everything around us can be better understood with mathematics. Math can sometimes seem abstract, but it is found easily in everyday life. For example, if you drop a pebble into a pond, then you can see the circles that ripple out, right? So those are all concentric circles. Do you know concentric circles?
Yes, sir.
So you may define concentric circles like this. Concentric circles are circles that are of different sizes, but share the same center, right? So share the same center, and this means the center is where? The center is where you are dropping the pedal, right? So in the same manner, you can observe different geometrical shapes nearby in the nature. So different patterns in nature are visible and found in the natural worlds. So you can observe different geometry. You know, geometry is where geometry is with arithmetic and one of the oldest branch of the mathematics. Do you understand? And it is concerned with the properties of space that are related with distance, shape, size, and relative motions, etc. You also calculate the you also see the three-dimensional objects in your life, and you can easily calculate its volume, surface area, etc. with the help of its shape. And you can apply mathematics to calculate all these things. So mathematics is viewed not only as useful as a way of thinking, seeing and organizing the world, but also as aesthetic and worthy of pursuit of in its own right. So I think I think students should think about mathematics. If they want to learn the mathematics, they will have to think. Continuously think. They will have to continuously think about this, because if you will not think, if you learn it, then you will never understand the concepts. Okay. So at last, I wish the students a very prolific and beneficial this platform. I think I should end with this. So if you have any query, I think you may ask.
Before children ask, sir,
okay.
I think I realized today, had I got a teacher like you, I wouldn't have been victim of the subject. Wish I had a teacher like you. Thank you so much.
Thank you very much, man. Thank you very much.
Thank you, sir, for solving us so many queries. Let us greet Professor Lakshmidhar Behera now.
Okay, thanks.
Okay, thank you, Khushi, Akhya, and Purnima Ma'am, Dr. Arvind Singh from BHU, and all the teachers, students who are all there. Thank you very much for. I would share my screen because I will just take 5-10 minutes to speak. about the import of zero and infinity. Before I start speaking, let me tell you, you are all students, you study history to understand the human behavior. You learn language for communication. You learn science to understand the physical world or the world of perception around you. And you also learn mathematics. Mathematics also is another language. Without mathematics, science won't exist. But mathematics helps us to quantify things around us. So also, but here today, let me share the screen. Share screen. Can you enable my screen sharing? Who is the administrator? Someone is working?
Yes, we are working.
So, okay. All right, so I got it. So let me check to a whiteboard probably. Okay. Maybe. There is always some technical glitch. Where is
We are working for the smooth functioning, sir. We have already worked. It is at your end you have to receive.
yeah? Where is this screen? It is not showing.
Where is the screen? Batao.
Okay, I got it. Thank you. So you can see my screen now. Are you able to see?
Yes, yes, we can. Yes, yes. Principle of.
Okay, so good. Thank you. So what is zero, my dear students? Why it is not working here?
Good morning, sir.
Yeah.
Sir, it's from your end only. We have shared the screen. Yes,
Okay.
Sir. Now it's on. Yes, sir.
My it doesn't work. Okay. I think it should work now. Let me check the. Somebody is scribbling there probably. Okay. Zero and infinity. Are you able to see what I'm doing?
Yes, sir. Yes, sir.
Okay. What is zero and what is infinity? You have seen in math, right? Suppose I say limit x tends to 0, 1 upon x is, can somebody say what is the meaning, what will the output here we write? Anyone?
Infinity.
Infinity. Okay. This is infinity. That's what we write. But you see, my dear friends, we don't make x equal to 0, nor in math we know what is the infinity, except when Cantor talked about infinity as a mathematical object. I will just let you know the beauty of 0 and infinity, and I'm going to make a personal connection with each one of you. I hope you will enjoy it. Let me start with what is 0. So let us say, suppose I say 0 to the power 0. Anybody knows what is this answer?
Not defined.
Not defined. Anybody else? Somebody said this is not defined. Yes? Suppose I say x to the power x, limit x tends to 0. Can anybody say? Okay, so because I don't have also time, I cannot give a class here. I will go very fast. All of you know 1 to the power 1 is how much? 1 to the power 1.
Sir, it is 1.
1. Suppose I write 0.9 to the power 0.9. You will get approximately a value 0.9. Okay. And similarly, if I do 0.8 to the power 0.8, right? You will get a value point. You can, if you have a calculator, you can do it. 0.8 to the power 0.8. It is approximately 0.83. Right? Now you can do that. Let's say I will reduce further, 0.5 to the power 0.5. So if I use a calculator, I will get 0.5 to the power 0.5. That is 0.70. That is 0.70. So you can see this is reducing, right? As I'm going down, it should reduce. So obviously, what you would expect, 0.0, as we go towards 0, then it should reduce. It doesn't happen. Suppose I take another value, 0.4 to the power 0.4. You get 0.769. 0.3 to the power 0.3. I'm reducing, right? And I still get 0.69. 68 increased. So let me show you what happened here. 0.4 to the power 0.4 is something like 0.67, and 0.3 to the power 0.3 is 0.6, approximately 0.68. So that means it started increasing here. Now if I say 0.1 to the power 0.1, this will become 0.1 to the power 0.1. So that is 0.79. You see? So that is 0.79. So it is increasing. So if I make 0.01 to the power 0.01, this value will be 0.01 to the power 0.01. So that is 0.955. So obviously, if I say 0.00001 to the power 0.00001, you can easily say this is 1. So this value, I can put it here as 1. Now, but what is 0? I still didn't understand. I still didn't understand what is 0. Suppose I write 10 to the power minus 99. This is still not 0. Suppose I write 10 to the power minus 999999999. This is still not 0. Just try to see. That means 0 is something that you cannot conceive mathematically. You cannot conceive. What is 0? When it will be 0? Like for example, there is a line here, 0 to 1, right? Then suppose I want to find out what is the next point after 0, right? Like suppose there is a natural number, 1, then 2, 3, 4. And you add one more, you get 5. Add one more, you get 6. But after 0, this is called real. This is a natural number, and this is a real number. From 0 to 1. So let us say in the middle there is a number called 0.4, 5, 6, 7, 8, 9, and so forth. Let us say this number. But how do you get from 0 to this? You cannot say from 0, what is the next number? After 0, what is the next number in this real line? Is it 0.00001? 0.0000001? 0.0000001? So my dear students, mathematics is a lot of fun when you start thinking about it. Otherwise, it's a very boring thing if you simply look at the operations, mathematical operations. So now what I told you, what is 0? Mathematically, you cannot say what is its value. You can say it is nothing, that's all. But it has no value, 0. No, what is 0? So to reach 0, I cannot reach 0. Suppose I have some value. If I have to reach 0, I don't know how to reach 0. Just like if I talk about infinity. Now, infinity. In infinity, suppose I put 1, 2, 3, 4, and so on. When can I make it infinity? Nobody has this answer. But Cantor agreed. Cantor said there must be infinity. You know why? Because he said, suppose you have this irrational number, let us say pi. You know this series, 1, 4, blah, 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 goes on. So this series, suppose I stop somewhere, then ideally pi will cease to exist. It is no more pi. So for pi to exist, I must allow this series to be infinite. I cannot terminate anywhere. And that is how Cantor talked about infinity. Okay. One of the things that Cantor talked about infinity is, suppose I have a natural number 1, 2, 3, 4, 5, 6. And then I have odd numbers 2, 4, 6, 8, and so forth, right? And Cantor said, suppose this is my original natural number set. You have a basket, you put all these numbers there, and you collect these numbers, 2, 4, 6, 8, and take away. So what is left? Everybody would say 50% would be left. But Cantor showed, no, the original natural number set still is there in the basket. You have lost nothing. How did he do it? He took a basket here, he took another basket here, and he started 1, 2, 3, 4, 2, 4, 6, 8. And he started developing one-to-one correspondence between one number from here to that number using set theory. And he showed that the size of this set and size of this set are same. That means in infinity, if I say infinity plus infinity, that is infinity. Infinity minus infinity is also infinity. Not only that, Cantor also talked about a very interesting, because there is a big topic. Suppose there are rational number, right? Rational number, I can write 0 by 1. Let me know, because 0 is not a rational number. 1 by 1, 1 by 2, 1 by 3, and so on. This goes on up to infinity. 2 by 1, 2 by 2, 2 by 3 goes until infinity. 3 by 1, 3 by 2, 3 by 3 goes until infinity. And you can see these are all rational numbers. And they are all infinite. Okay? But Cantor showed that this also has the same size as that of the original natural number set. How he did it? He did it very nicely. He started counting the numbers. He first went straight arrow, then diagonally, then again straight, and then up, right? And then like this, and like this. He could make a back and forth, and he can count everything. So 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. He actually he produced by counting the same original set. So it appeared that, you see, this is from 1 by 1 to this is one infinity set. This is another infinity set. This is another infinity set. There are an infinite number of infinite set by normal logic. But Cantor showed that this whole thing is simply a same original set. So basically, of course, if I go to a real number, then that becomes uncountable infinity. Then we talk about cardinal number. I will not conclude my lecture. I just wanted. So what we talked about 0 and infinity. And we saw this is also inconceivable. This is also inconceivable. What is meaning of inconceivability? You see, inconceivableness, the mathematics at the level of finite. We all do finite mathematics. Dr. Arvind Singh also would agree. We all do finite. Even if we use infinity in math, that is simply a large number. It is never an infinity. And what is, there is a verse in Ishopanishad invocation mantra, Om Purnamadam, Purnamada, Purnamudachyate, Purnasya, Purnamadaya, Purnamavavashishyate. So it says the absolute is so infinite and complete, even if you take out infinite complete units from it, still it remains the same complete. That is the idea of Ananta. So this is called Ananta. or infinite. Or we also say God, not God, your imagination, God as it exists as all pervading or all embracing. Whereas zero in our literature is talked about prashanta. Prashanta. Prashanta means absolute peace, tranquility. And if someone is very rich, very wealthy, but if he's detached from everything that he has, then he cannot be prasanta, but at least he will be santa. Not prasanta, but at least he will be santa. For example, somebody is very intelligent, but if he's attached to that intelligence, you will find arrogance within him. But he's detached from that intelligence, then you will see santa in him. Peace. We all look for peace. And zero and infinity is something that can give us a lot of boost in developing our very affable personality. A personality that is embracing. Like there is a verse in Bhagavad Gita which says, Brahma Bhuta Prasannatma na sochati na kankhyati sama sarvesu bhutesu mad bhakti lavete paraham. That is, a person who is situated in Brahma Bhuta, Santa, and he has no lamentation, no hankering. No lamentation means he doesn't look at past. No hankering, he doesn't look at the future. Sama sarvesu bhutesu. He is equally disposed to everyone, all embracing. Mad bhakti lavate paraham. He is blessed by the Lord. He is specifically blessed by the Lord. So, zero and infinity, mathematically intractable quantities, but has profound impact in our spiritual personality development. Thank you very much.
So I think Professor Behra, you explained very well the number system, and I think you explained this complicated phenomena in very easy manner, I think. And this is a very complicated complicated topic in the number system, I think. So and I saw that your capability of your capability of describing all these things were very good. So thanks.
Thank you, Dr. Singh, for your compliment.
And here I would like to add, as a student of literature, sir, we thought only we studied peace, love, harmony. But coming from maths today has actually made me rethink, why did I not choose maths as a first option? For everything in universe, if it is used the way you've explained, the peace that transcends all human minds, love that binds us together, all pervading, as you said, I'm sure the world will be a happier and a nobler place to live in. Over to dear children for, and thank you for, opening, I would say, an inward eye within us, that how maths also can, as literature, can reach out to people. Thank you so much, sir.
Thank you.
That was really motivating and inspiring, sir. Thank you, sir, for your kind words. Now, moving ahead to some mind-boggling exercises. We are here to cater your calculative abilities. Please note that you are requested to type your answers in the chat box along with your school codes. and not unmute yourself for the same. The candidate who gives the right answer will receive the e-certificate via email. The first question is, the point of intersection of medians of a triangle is known as? I shall repeat the question. The point of intersection of medians of a triangle is known as? I will move forward to the next question. How many odd prime numbers are there between 1 and 15? I will repeat. How many odd prime numbers are there between 1 and 15?
Voila! We are getting number of answers here.
I shall now move to the next question. What is the sum of all one-digit prime numbers? I shall repeat. What is the sum of all one-digit prime numbers?
Wow, so we have answers pouring in. Good participants, keep it up.
M118B5 says the 5 is the answer.
The next question is, how many digits will be there in the square root of a 7-digit numeral? I will repeat. How many digits will be there in the square root of a 7-digit numeral?
Come on, participants, we have another question coming now. Be quick.
So here comes the last question. Which is the smallest Ramanujan number? I repeat, which is the smallest Ramanujan number?
That's good to see. Correct answers, and let's see who was the fastest finger first, and they will get the e-certificates through mail.
I request respected Principal Ma'am to enlighten us with her words.
teasers, checking the intellectual levels, and a lot of fun together. With this, I wish all the teams good luck. for the days to come. And I declare Mathematica 2020 open. Good luck to all of you.
Thank you, ma'am, for always motivating us. Being Allenites, it's our pleasure to always explore the new benchmarks of learning. Now, I request Vice Principal ma'am to deliver the vote of thanks.
So much. Any amount of thanksgiving is less. I have always believed so. And so shall all be. Let us begin with thanking Almighty who brought us all together here to work as per His wisdom and take these legacies forward. Next in line would be our CMD sir, Mr. Mukhtarul Amin, ever motivating, ever paving the path. Would like to thank our Vice Chairperson, Ms. Shahina Amin, ever loving, ever concerned. Our Director of Superhouse Schools, Ms. Nosheen Shahdar, ever guiding, ever leading. The Principal, Ms. Ruchi Seth, who's been all along as a guiding force. We thank all these people amidst us. And also, we would like to thank the two chief speakers we had who actually, threw some light on how math as a subject or how everything in the world which is connected all leads to one, Paramatma, the spiritual being in all of us, making us more humane and more human. Thank you all. Also would like to thank our team Mathematica for putting up a good show. Well, we cannot deny some technical glitches, but I think that has become a new normal. We also would like to thank here each one who's been with us around, all the participants, all the school principals who were kind enough to send their participations, and all the viewers there or live on FB. Nice it is to have you all with us. Thank you and God bless.
Thank you, ma'am.